This question is connecting cities with minimum cost. So you're given an array, 2D array, x, y, and cost. And then the idea is return the minimum cost to connect all the cities. And then if not possible, return -1. So this question is pure BFS solution. So what you need to do is you want to build a graph, and then the graph is going to be traverse from cities to cities. So city 1 to city 2, and then with the cost, right? Cost. And then later on, after you traversal, you want to check the cities you visit is equal to the n. If not, then you return -1. So it's straightforward, right? So I don't need to go through like the diagram again, but so the solution is pretty straightforward. So I'm going to have a hash map, and then the cities is going to represent an integer, right? So I'm just saying int. And the neighbor for the node in is what? It's a list of integer, right? But what I want to do is I don't want to return a list of integer. I want to return a list of in array, which can store the neighbor and also the cost. So I will show you what I meant. So here's a so I need to traverse the connection. And then I'm gonna say A equal to connection 0, B equal to connection 1, C is cost equal to connection 2. So again, I need to say map.compute if absent. Um, and then I'm initialize my AS key, and I need to also initialize my list, right? So X and a new array list. And then I need to what? Add the cost. So new int. So A to B cost by what? By cost. I mean, if I know the distance, it's a cost for distance, right? And then this will be exactly the same thing. If it goes from A to B, is the cost, I mean, the distance cost, right? So let me just rename distance cost. If this is A to B, then it's going to be the same to B to A, right? So that's straightforward enough. And then what we need to also do, we need to store as what? The visits node, right? So it's going to be hash set. And then also we want to know when we visit the node, we want to know which is the one should go first. So the priority queue will comes into here. So it's going to be in array because I'm traversing the node and then with the cost, right? So and comparing, and then I'm storing the cost at what, index 2, and pq.add and a new int, and then the beginning is going to be what, 1, right? Yes, definitely 1. Yes, just 1. I don't care, just 1. And then let me explain what's happened here. So it's going to be source node for the first index, destination node for the second index, and then cost for the following index, right? So I'm gonna have a result, and then later on I will basically return a result, which is going to be the total distance. But before that, I need to make sure if my visits size is equal to n. If this is true, I traversing all of the node and can return result. If not, I'm going to return -1. All right, so pretty straightforward, and then that's it. So I'm still traversing. So pq dot is empty. So I pull the first node out, which is 1. I starting from 1, and then I'm going to say node.pq pull. And then once I pull the node, I'm going to say source equal to what? Node at 0. Destination equal to node at 1. House at node at 2. So if the visit dot contains, The source? I mean, sorry, the source is definitely visits. It has to be destination. If the current iteration and then you poll which you have visit, you don't want to traversing, right? So imagine you visit 2 again. You don't want to revisit again based on the 3, right? So again, you want to continue, like you want to skip, right? And then this is line 23 is going to be what? The new node. So you want to just add in the what? The cost into the result. And then you mark the current node equal to visit, right? So it's going to be what? Destination. So how do I get a new neighbor from the destination? You want to traverse the destination from the graph, right? So for int neighbor and then get the destination. From the destination, you want to get a new neighbor. You want to think about this. From the destination point of view, you want to get the new neighbor from the destination. So you can keep traversing. You don't want to get the source because source you already know the source. You want to know where is the new neighbor from the destination so you can keep going. So we don't need to check is content or not. Just say just offer new int. And then from this one, the destination become the source. The neighbor become the what? The neighbor become the first I mean sorry, the neighbor becomes the neighbor has this int. I'm gonna say new destination, something like this. You go to new destination to 0, and also the what? New destination distance cost. New destination distance cost equal to neighbor 1. So how do I get this? It's right here, right? So I know my destination, which is A. I want to get a new neighbor, right? From the destination point of view with a new cost, right? So what I need to do is add new destination right here and then new destination distance cost right here. So once I get it, I will be able to iterate it, right? To be good. Okay. Oh, it's fine. Anyway, so the time and space right here, this is space. This is space. So the worst case is adding all of the node into the the map and the PQ, right? Definitely you need to add, right? Otherwise you are not allowed to return, right? So the space is going to be all of n time. This is time. Time is going to be all of n, right? You want to traverse all of the connection, and also you want to traverse all of the node, right? So this is also all of n. But the PQ is what? A log n, right? You want to find out the sorting. So the worst case for the time is a log n. So n represents the number of CD, which is this one, right? So that's the solution. All right, see you later. Bye.